Here we have an equation with variables on both sides. 3x minus 7 equals 3x minus 7. Okay, I'm assuming that some of you are looking at this and you know exactly what the answer is, and you can skip right ahead to the end of the video just to make sure. But for those who are not sure what's going on here, I'm going to explain it in a little bit more depth. Okay, so when I have an equation with variables on both sides, the first thing I always do is make sure each side is simplified. Okay, and I see in this case it is. I see variable term, constant term on the left, variable term, constant term on the right. So it's simplified. So the next thing I want to do is get those variables on one side of the equation, because I can start solving until I have the variables on one side of the equation. In order to do that, I need to subtract this 3x so that I'll have nothing left there, right? 3x minus 3x is 0. Gone. No variable on that side. If I do it on one side, I have to do it on the other side. So let me see what I get. 3x minus 3x, oh, it's 0. Wait. So now I have no variables on either side. What am I left with? I'm just left with negative 7 equals negative 7. Okay? So I see something that makes sense, but I don't see a value for x. What's going on here? Well, if we look back at the original equation, 3x minus 7 equals 3x minus 7, you see you have exactly the same thing on both sides of the equation. When you have exactly the same thing on both sides of the equation, we say that this equation has infinitely many solutions. Okay, it has infinite solutions. What does that mean? That means an endless amount of solutions, right? Just as it sounds. That means anything I can put into this equation will give me a true statement. Why? Because if I take 3x minus 7 and instead I make it 0 for x, it's exactly the same thing. It's definitely equivalent. It's the same thing on both sides. So they're equal. 0 minus 7 equals 0 minus 7. I can put 20 in there. 3 times 20 minus 7 and 3 times 20 minus 7. Will it work? Yes. It's 60 minus 7 and 60 minus 7. So it's 53 on both sides, right? Whatever I put in, it's always equivalent. It's always a true statement because it's exactly the same thing on both sides of the equation. So that's why we say that this equation has infinitely many solutions. Then we have another kind of equation, like this one. It looks kind of similar because they both have 3x, but it's different. Why is it different? Because now when I subtract 3x, because I'm trying to get my variables on one side, I get 0 on this side, I get 0 on this side, that's the same. But what's left is 5 equals negative 2. Wait, I didn't get a value for x, but I also got something that does not make sense. 5 does not equal negative 2. Okay, so this has no solution. This is something that just doesn't make sense. Okay, because I'm taking the same term, 3x, and on one side I'm adding 5, and on the other side I'm subtracting 2. That can't possibly be balanced. Whatever we put in there for x, we're always going to have something that doesn't make sense. If we put 0 in there, we're going to have 0 plus 5 and 0 minus 2. Doesn't make sense. Let's try it with something like 3. So if I put 3 in there for x, I have 3 times 3 equals 5, and 3 times 3 plus 5, and 3 times 3 minus 2. So 9 plus 5 equals 9 minus 2. 14 equals 7. No, doesn't make sense. Anything I will try will not make sense because I have the same term, 3x, but I'm doing two different things. One time I'm adding 5, one time I'm subtracting 2. Can't possibly be equal. So this is an example of a problem that has no solution. Okay, so when you see the same variable term, but a different constant term, no solution. Going back to the other one, same variable term and same constant term, infinite solutions. I can put anything into that equation and it will work.